Okay, let's go through the free response questions on the modern physics unit. 54 says determine the energy of a photon in electron volts, and we are given a frequency. Well, we're going to go here. Let's get the right out. Modern physics. Frequency, energy of a photon. There's two equations, right? But we're going to use the top one. The top one is going to be giving it in joules, and the bottom one is giving it in... oh, interesting. Okay. So note, you probably want to do these in reverse order. These questions are put in here in the wrong order. So let's start with the frequency, and we're going to start with number 56. So we have 5.48 times 10 to the 14th hertz. What color is this? Here, reference table, crinkled reference table, 5.48 times 10 to the 14th. So notice these are in reverse order. So 5.2, this is bigger than 5.2. 5.4 is here, and it's less than 6.1, so this would be green. Calculate the energy of the photon in joules. Okay, this is why I had it in reverse order, because once we get, starting with the frequency, it's much easier to get it in joules and then convert it to electron volts. Otherwise, you're just going in reverse order. Okay, what is the energy in joules? Well, if you want to do it in joules, you're going to start with this equation, H times F, or Hc over wavelength. Now we're given the frequency, so it's going to be Hf, which is, and if you look it up, the Planck's constant, 6.63 times 10 to the negative 34th. And this says show all work including equation, substitution with units. Remember, units are given on these a lot of times. Units might not make sense at first, but let's see, this should be joules times seconds for Planck constant. Joules times seconds times the frequency, 5.48 times 10 to the 14th. And frequency is in hertz, which is 1 over a second. So when you can't multiply seconds times 1 over a second, those go away. Those actually cancel each other out. That leaves you with an answer in joules. 6.63 e negative 34 times 5.48 e 14 should get us something to the negative 20th power, or close to it. Yes, 3.63 times 10 to the negative 19th joules. Okay, now let's go to electron volts, because converting from joules to electron volts is simple dimensional analysis. We have 3.63 times 10 to the negative 19th joules, and this doesn't actually ask us to show our work. And we want to get rid of joules, and we want to change it to electron volts. Well, if you look on the first page of the reference table, you see 1 electron volt, 1 eV, is equal to 1.6 times 10 to the negative 19th times 10 to the negative 19th joules. You'll notice the negative 19th powers cancel, so you end up getting 3.63 over 1.6, which is equal to 2.27 times 10 to the negative 19th. I'm sorry, 2.27. The negative 19's canceled out. Electron volts. So 2.27. It could be that you would need to actually figure out what transition this was. I don't think they don't ask it for here, but you could look here and say, well, what's 2.27? And maybe you end up getting, I don't know. That's 2.84. That's going to be, so I don't know what it would be. 1. So I don't know. You could probably figure out a transition in here. I'm not going to spend a lot of time doing it. But they might give you multiple choice question or something that did that. Which one of these gaps from like E to B or from F to B? Like, so F to B would be 5.74 minus 2.68. So that's 3.06. So that's a little bit too high. So there's probably a transition there someplace that's 2.27. Okay. Oh my gosh, let's look at this next one. This is a long one. For years, theoretical physicists have been refining a mathematical method called lattice quantum, and you're probably just blanking out here. So let's skip to the question and let's just say, explain how it's possible for a colliding proton and antiproton to produce a particle with 6 times the mass of either. Well, let's think about it. How do you produce mass when you don't have it? So you have to have energy, right? So where are this energy coming from? Well, they're talking about beams of protons moving at 99.9% the speed of light. The only number in here, it just kind of jumped out at me. I mean, there's a couple numbers that are spelled out. And there's a 1.0 kilometer. So maybe it would be kinetic energy of particles becomes mass. So you're converting energy into mass. Okay, determine the sign and the magnitude of the charge of the BC particle in elementary charges. Okay, well, you're like, how am I going to get this? Okay, so let's see. We're probably going to be doing conservation of charge. So calculate the mass of the rare BC particle consisting of a charm quark, a bottom antiquark. Okay, so that is a meson of some sort, and we can look here at the standard model. So BC is made up of a charm and a anti-bottom. So a charm quark has a charge of plus 2/3. A bottom has negative 1/3, but an anti-bottom would have plus 1/3. So 2/3 plus 1/3 equals 1e. And the answer has the right units, elementary charges. If you wanted coulombs, it would be 1.6 times 10 to the negative 19th. There we go. And we know that it is made of a quark and an antiquark. That means that it is a meson. You might be able to get away with saying hadron, but meson is a better answer. Okay, so there's a lot to unpack in here, but sometimes if you look at the questions, you can be very selective about what you read and not spend a lot of time wasting reading stuff that may be interesting, but is not relevant to this particular question at this particular time. And is very, very dense, like would be difficult and intimidating to read sometimes. Let's find the wavelength of a photon of light with this amount of joules of energy. Okay, so again, if we're dealing with joules, it's going to be h, either frequency or hc over wavelength. We want wavelength, so that means wavelength is going to be hc over energy, which is 6.63 times 10 to the negative 34th joules times seconds. Let's get the units in there. C is 3 times 10 to the 8th meters per second. And energy is 3.26 times 10 to the negative 19th joules. I have the equation. Do I need that? I have the substitution with the correct units, and then it is just a calculation. And again, make sure you use parentheses and or the E button. 6.63 E negative 34. Whoops. 6.63 E negative 34 times 3E8 divided by, and I'll put parentheses in here, 3.26 E negative 19. And we go to get an answer of 6.1 times 10 to the negative, and this is, I hate it when it does this, 1, 3, 4, 5, 6, 7, negative 7th meters. There we go. Answer with the correct unit attached. '61 and 62, blah, 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 blah. And, this might be important, but before we get there, we got a data table. Let's look at the question. Determine the energy in mega electron volts produced in the reaction of a proton with a lithium atom. Okay. Mega electron volts. There's only one place we've seen mega electron volts so far. We've done electron volts, but mega electron volts, the only time we've seen it is right here when converting mass, when it is in the universal mass unit, into energy. So let's say that it probably, and you look here, it's giving us mass in universal mass units. We need to figure out how much mass to convert. So let's think about this, produced in the reaction. So this is a little tricky. But we can just figure out, hey, what's the initial mass? So the initial mass has an alpha particle. So it probably tells us what these are, right? We have lithium atoms producing alpha particles in energy. So we have a proton, bombarded lithium atoms producing alpha particles in energy. Okay, so initially we have a proton that has a mass of this, and a lithium atom, and a proton is just a hydrogen, right? Lithium atom with this mass. So that is your initial mass. This is your final mass. Let's figure out how much mass is lost. So initially, you start with 1.00783 plus 7.016 atomic mass units. Let's put that in the calculator. 0.00783 plus 7.016 gets us 8.02383 universal mass units. You end with 2 of those. So you're going to subtract from that 2 times 4.00260. So that's my starting mass. That's my ending mass. If we subtract the 2, we'll find the difference. So minus 2 times 4.0026. Don't need another 0 at the end. And lo and behold, I find that some mass is lost. 0.01863 universal mass units. So it's a very small amount, right? But I know that it doesn't take a whole lot of mass to get a whole bunch of energy. So this is in universal mass units, and we're not using E equals mc squared. I mean, we could in theory, but we'd have a lot of conversion. We'd have to convert this to kilograms, and then we get answers in joules, and then we'd have to convert it to electron volts and omega electron volts. We can just simply say dimensional analysis. We know we need it in MeV, and we need to get it out of universal mass units. And we can look here, and we see 1 universal mass unit is equal to 9.31 times 10 to the second, or 931 MeV. So then it's just, that cancels this, so you end up with 931 times that number, which gets 17.3 mega electron volts. 17.3. Determine the difference between the total mass of the reactants and the total mass of the products. So again, these probably should have been in different order. We did that already. We did 0.01863 universal mass units. Here we go. In a mercury atom, an electron moves from I to A, and light is emitted. Determine the energy. So E photon equals E initial minus E final. Now I tell you, I can't even do this from memory. So we need to look at the energy level diagrams. We're dealing with mercury. We start in A. We start in I. So negative 1.56 electron volts minus the final, which is negative 10.38. So that's negative 1.56 plus 10.38. So I tend to write it 10.38 minus 1.56. Either way works. And you get 8.82 electron volts. Add the units there. Cool. A tau lepton decays into an electron antineutrino, and a tau neutrino, as represented in the equation below. So you get a tau lepton, and you could find those on here if you really wanted to. Negative 1 charge becomes an electron plus 2 other things. Show how it obeys the conservation of charge by indicating the amount of charge on each particle. Okay, so we need to figure this out. A tau neutrino, let's look here, over here, tau neutrino has a charge of 0, 0 e, becomes an electron. We know an electron has a negative 1 e, plus a electron antineutrino, B sub e. That's hard to see e, but it tells me there. Electron antineutrino. Let's look on the reference table. Electron antineutrino has a charge of 0, even though it is an antineutrino. It would have the opposite charge. It still has 0. So there's no difference between positive and negative 0. Plus a tau neutrino. So a tau neutrino here is, I'm sorry, tau neutrino here is 0. So what did I do wrong? Because a tau neutrino should be 0, 0, 0, tau. Oh, I made a mistake. Okay, tau right there. That's a tau particle. Maybe I looked at neutrinos originally. Tau has charge of negative 1. So the tau neutrino, a tau particle, has negative 1 charge. The electron has negative 1. And both neutrinos have 0 charge. Conservation of charge, negative 1 on the left side, becomes negative 1 total on the right side. Okay. So I think a lot of these questions might be in reverse order. I need to make a note of myself to fix that in the future. Let's see. A photon with a frequency is excited. It ejects, forming an ion. What's the number of the lowest energy level? Calculate the energy of the photon. Determine the energy in photovoltaic. So let's start with 67 because I think they're probably in reverse order. And we know E equals H times F, which is 6.63 times 10 to the negative 34th joules times seconds times the frequency, which is 5.02 times 10 to the negative 14th hertz. Sorry, not leaving a lot of space. I also forgot the no, I did include the equation. Substitution with units. Now let's solve it. 6.63 e negative 34 times 5.02 e negative 14 gets me 3 point. There's a problem there. Definitely should not be something to the 47th power. Let's try that again. 6.63 e negative 34 divided by 5.02 e negative 14th. There we go. Just double check your math, make sure the numbers look right. 1.32 times 10 to the negative 20th joules. And electron volts. Let's take that 1.32 times 10 to the negative 20th. And we know that is in joules, so we want to get rid of joules and we want to turn it into electron volts. And 1 electron volt is 1.6 times 10 to the negative 19th joules, again from the first page of the reference table. So we divide that number by 1.6 e negative 19, and that gets us 0.0825 electron volts. Pretty low electron volt. What is the lowest, what's the number of the lowest energy level that contains an electron that would be ejected by the absorption of this photon? Something seems a little bit off here. Let me see. 6.63. And I just say that because I look at this here and I'm saying this is a less than 0.1 electron volts. And you look at the ionization, and just to go from I to J would require 1.56 electron volts. So why is that so far off? That's totally wrong. That's why Here we go. 6.63 times 10 to the negative 34th times 5.02 times 10 to the negative 14th gets me 3.35 times 10 to the negative 19th joules. So always good to double check your math. Even look at your calculator as you're punching numbers in. So let's take that number and multiply it by 1. I'm going to change that. 3.35 e negative 19th joules. Okay, so we take that, divide that by 1.6 e negative 19th gets me, and we'll get a better number now, 2.09 electron volts. Now let's look at this. Okay, 2.09. So 2.09, if we gave 2.09 to something in I, it would only need 1.56 to escape. So sure, H only needs 1.57 to escape, so what could do it too? G needs 2.48. This is 2.09, so G could not escape. So you could escape from levels I or H. So what's the lowest that could contain an electron? So the lowest level is H. I could also, but H is the lowest. There we go. More psi than phi. Physics creates antimatter. Blah, 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 blah. Lots of text. Article from 2002. There's a lot to read. Let's just see this. According to the article, why is it a mystery that the universe seems to be overwhelmingly composed of normal matter? So let's read. Let's look for the word matter even. Corralling clouds of antiparticles into a chamber loaded with detectors and electric fields, and physicists assembled antihydrogen atoms. According to standard theories of particle physics, the antimatter universe should look identical to our own. Antihydrogen and hydrogen should have the same properties. Antimatter has been existing since 1927. Matter can only be created in antiparticle pairs. So if matter is created in equal numbers, it says that is a mystery why we seem to have mostly matter and what happened to all the antimatter. So matter is created as particle, antiparticle pairs. How should the emission spectrum of antihydrogen compare to the emission spectrum of hydrogen? Well, what they tell you is that particles like antihydrogen and hydrogen should have the same properties, emitting the same exact frequencies of light. So they should look the same. The thing that's going to be different is the charge. The author of the passage concerning antimatter incorrectly reported the findings of the experiment on antimatter. Which particle mentioned in the article has the charge incorrectly identified? That's an interesting question to ask, because I bet you most people don't look at that there. So let's look at it here. So let's look at charges. Coralline clouds of looking at hydrogen. Positively charged proton, that's true. Negatively charged electron. In antihydrogen, the proton's counterpart is a positively charged antiproton is circulated by an antielectron. An antielectron, by the way, is called a positron. But if a proton is positively charged, then a proton's counterpart, an antiproton, should be negatively charged. So antiproton is negative. I'm going to be specific, negative 1e charge. So there was a mistake. There's so much to digest in these long ones. They're really tricky. Okay. We're doing all right now. We're getting close to the end. A proton were to combine with an antiproton, they would annihilate each other and become energy. How much energy would be released? So we want an answer in doesn't tell us what units. So there's different ways to do this, but the easiest way, I mean, honestly, there's a couple ways to do it. I mean, you could assume that a proton and an antiproton were pretty close to 9.1 universal mass unit, 9.31 times 10 to the second. They're not exactly. You could instead maybe do the rest mass of a proton, which honestly isn't always the same as the moving mass of a proton, so is it going to be any more accurate? Who knows? But let's do that instead. So we're going to do, if we're going to work from kilograms, we're going to do equals mc squared. So mass is 1.67 times 10 to the negative 27th. C squared is 3 times 10 to the 8th meters per second. And I'm going to add a number in here because we're dealing with two particles, right? A proton and an antiproton. So there's two of them, so I'm going to double this because there's two particles. And technically this is the mass. The mass is twice that. So twice the mass times c squared. Let's not forget the square there. So then I can calculate it. 2 times 1.67 e negative 27 times 3 e 8 squared. And then I got 3.006 times 10 to the negative 10th joules. Determine the frequency of a photon whose energy is, okay. So E equals HF. We're going to solve for F. F is equal to E over H, which in this case is 3 times 10 to the negative 19th joules, divided by 6.63 times 10 to the negative 34th joules times seconds. Our units will be 1 over seconds. So 3E negative 19 divided by 6.63 E negative 34 gets me an answer of 4.5 times 10 to the 14th hertz. I don't have enough space in here, I apologize. Is this the only energy? Okay. I feel bad, these are all backwards. Okay. Determine the energy in electron volts of a photon emitted by an electron as it moves from N6 to N2. So I really need to start this at number 76. So going from N6 to N2, N equals 6 gets you initial energy of negative 0.38 electron volts minus a negative N2, 3.4 electron volts. I didn't write the equation. It's E equals EI minus EF. So 3.4 minus 0.38 gets me 3.02 electron volts. Didn't ask for an equation, so I didn't write it down. Convert it to joules. 3.02 EV times energy in joules gets me 1 electron volt is 1.6 times 10 to the negative 19th joules. So 1.6 E negative 19 times 3.02 gets me 4.832 times 10 to the negative 19th joules. Let's find the energy, the frequency. So frequency is equal to, same equation I used there, energy over the Planck's constant, 4.832 E negative 19 joules. Got an equation, 6.63 E negative 34 joules times seconds. 6.63 E negative 34 gets me 7.29 times 10 to the 14th hertz. It says is this the only energy or frequency that an electron from n equals 6 could emit? And the answer is no, because you could go from 6 to 5, you can go from 5 to 4, you'd have a line for 4 to 3, you'd have a line from 3 to 2, you'd have a line from we're going from, let's see, 6 to 2, so you could go from 6 directly to 4, you could go from 6 to 3. We have the 6 to 2, which we did already, but I'll write that down, 6 to 2. So you could go from 5 to, instead of 5 to 4, 5 to 3, you could go 5 to 2, you could go 4 to 2, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about 10 different lines right there. So there's a lot of them. My explanation might not be great, but if you're listening to me, you understand what I'm saying. Okay, 77. A uranium nucleus emits an alpha particle. The total mass is less than the mass of the original uranium nucleus. What happened to it? It was converted into energy. E equals mc squared. How much energy is produced when, see, this is the nice simple one. We start with universal mass units. So I said E equals mc squared, but we're given it in terms of universal mass units. And so we can look and we see that one universal mass unit, we want to get rid of universal mass units. One universal mass unit is 9.31 times 10 to the second. That's 931 mega electron volts. So 931 times 0.25, that's a quarter of it. Should be about 200, yep, 232.75 mega electron volts. Okay. Photon has a full wavelength. I don't really want to do this. I've done a bunch of these for you already. You're just going to use E equals hc over wavelength. You know the wavelength, you know h, you know c. You can calculate that. Let's look at some of the other ones. The alpha lines. There's a lot of stuff here and just totally not enough space. Let me come back to that one maybe, and let me do this. What's the energy? See, use the answer in the previous questions to explain whether, okay. So it really should start with 63, the energy of an alpha line. So the alpha line is a wavelength of 6.58 times 10 to the negative 7th. So E equals H. I'm given wavelength C over lambda. So 6.63 E negative 34 joules seconds times C 3E 8 meters per second over wavelength, which is 6.58 E negative 7 meters. Put them in. This one's 6.3. E negative 34 times 3 E8 divided by 6.58 E negative 7 gets me 3.02 E negative 19 joules. 3.02 E negative 19th joules. I want to get rid of a joule and turn it into an electron volt. 1 eV is 1.6 E negative 19th joules. Joules go away. Divide that number by 1.6 E negative 19. And I get probably about 2 or a little less than 2. 1.89 eV. And it says whether this results in the alpha line from 3 to 2. So let's look at 3 to 2. 3 to 2 is basically from this level to this level. We can figure out what that energy is. E equals initial, negative 1.51 electron volts, minus a negative 3.4 electron volts. Take that, solve that. 3.4 minus 1.51 is equal to 1.89 eV. So the answer is yes. They have the same energy. Okay. If you look at 80, by the way, I mean, it's the same stuff that we've done before. Frequency, so you've got wavelength to frequency, frequency to energy, energy to electron volts. We've done a bunch of questions like this already. You just need to know if you want to find the frequency for number 80. The frequency is going to be equal to, and we're going back to the waves unit for this a little bit. So we do call on this every so often. speed equals frequency times wavelength. Well, that means frequency is your speed times your wavelength, v over wavelength. But v is really just the speed of light, so it's 3 times 10 to the 8th meters a second, divided by the wavelength, 6.56 to the negative 7th. So your frequency is going to end up being something to the 14th power. E8 divided by 6.56 e negative 7th. We get 4.57 times 10 to the 14th power hertz. And then you can go and do the other questions that you know how to do. Let's finish this up. Since charge is conserved, what charge must an electron antineutrino carry? Okay, well, you want to do the easy question or the hard way? Because the easy way is we look at this and we say, electron neutrino is on this. Electron neutrino has no charge, so an antineutrino should also have no charge, so it should be 0, but we want to prove it to ourselves. The neutron has 0 charge, the proton has +1, the electron is -1. Energy has no charge associated with it, so if the right side has to have the same side as the left side, it starts with charge 0. This has a charge of 0, so that has to have 0 also. +1 minus 1 plus 0 equals 0. Does the mass of the neutron compare to the mass of the proton? So, if we look at this, mass conservation, the left side, if you're producing energy, should be bigger than the right. Because I'm assuming that energy, it's saying the nucleus is converted into a photon. So you're turning mass into energy, right? So the mass of the neutron turns into the mass of a proton plus the mass of an electron plus an antineutrino, which is really low mass, plus energy. So the mass of the neutrino has to be the biggest of them all, because that's equal to the proton plus the electron plus whatever turns into energy. Mass of the proton. And so there we go, modern physics in a nutshell. That's it. Thank you very much for watching.